Hey everybody, welcome to Madden Science. Today we're learning about power. And not just about power, but about scientific thinking skills. Certain things like observation and estimation. Estimating, just like our good friend Enrico Fermi. So Enrico Fermi problems where kind of back of the envelope style, where maybe you don't have all the information, but you got to gather some from here and some from there and do your best with the calculation. We're looking at regular problem solving. Again, we may not have all the information at first, but you can do it. So for today's video, it's kind of a at-home problem solving that we're going to go along with me, pausing at certain points. I want you to break up your piece of notebook paper into thirds, kind of top to bottom, as we get more and more information. But it's really important that you stop to think as we're going and answer the questions and try and get comfortable with the challenges of even not knowing everything in its entirety at first. Well, all right, so let's talk about power. I want to talk about some old school video game power. Nah, not that kind of video game power. I'm talking more like this kind of video game power. And so that's really the central piece of today's video. Who's more powerful, Donkey Kong or Mario? In our first math problem. Donkey Kong came out in 1981 when I was 5. How old am I at the making of this video? All right, so our central question again is to determine who's more powerful, Donkey Kong or Mario. From the video game, you can see here the two are battling their way up the course through a series of ramps and ladders. Anytime we're problem solving, we probably want to start with thinking about what do we know, what are we trying to find out, what are we measuring, what are we calculating, and in particular for today, what is it that we're estimating? So yes, we're going to look at power, and we know that power is work divided by time, and work is force times distance. So if we look at that from a step back, that means we've got 3 things that we want to know. And we're either going to get them from measuring them directly or estimating them. And so you're going to need to use a video to do just that. So force is the weight of the object. In this case, Mario or Donkey Kong. The distance is how high they're going to climb up. And the time is how long it takes. So first thing we'll do is estimate the weight. And in that case, you'll probably need to go from pounds to newtons. And then you're going to estimate the distance vertically traveled. And then for time, use a stopwatch. Now, before we get into what's going on with Donkey Kong, I asked 3 friends to help us out with this, kind of doing their own real-life Donkey Kong, either climbing a tree, a slide, or a swing set. So to help us out, we've got Greg, Dan, and Katie coming to us from California and Illinois. Now, depending on your birthday, you're going to be in charge of calculating one of the 3's power. So if you were born between January and April, you're going to be in charge of Greg. If you are May through August, you're going to be in charge of Dan. And if you are September through December, you've got Katie. All right, so let's take a look at these videos. And in watching it, I want you on paper on the top third to estimate your person's weight. Go ahead from pounds to newtons. If you're not sure how to do that, we can look it up or go back to a previous problem. You're going to then estimate, probably based off their height, how high it is that they climb. Again, we're only concerned with the vertical component, not horizontal. And then you're going to use a stopwatch to measure how long it takes. So go ahead, pause the video, and do that right now. Let's start with Greg. Greg's force coming in at 800 newtons. He climbed to a height of 3.6 meters. And if we look here with the stopwatch, he took 11.05 seconds. So first thing is, how close did you get to those measurements? If you're totally off, no problem. Next is Dan. Dan is 755 newtons. He climbed a distance of 2.5 meters. and it took 15.21 seconds. And Katie clocked in at 620 newtons, climbed 3.3 meters, and took 7.11 seconds. Now from there, we're filling in our formula. Work is force times distance, and power is work divided by time. So that gives us this chart, and you can see from those three, the most powerful was indeed Katie at 287.76 watts, followed by Greg at 260.63, and Dan in third place at 124.10. Now go ahead and pause the video right here. Write down the information for all three, even if you only calculated it for one person. And from there, I want you to make some observations. Why is it that Katie came in first and Dan came in last? What kind of variables would have affected that or changed something? If you were involved, say at home, how is it that you could assure that you came out in first place? And now we're back to Donkey Kong, where Mario is battling all sorts of barrels, trying to get up to save the day and defeat Donkey Kong. And so if you look at it at first, of course you're going to think that Donkey Kong is more powerful. And why is that? Well, he's heavier, and he's moving faster. And he's not wasting time going horizontally. So let's look at this. Go ahead and stop the video. I want you to measure out as best you can, kind of like we just did with Greg and Dan and Katie. And through estimation, I want you to do your best at calculating the power of Donkey Kong and Mario. So pause the video right now. Go ahead and get kind of your first level of calculation, and then I'll give you a second level and a third. But for right now, you're doing the estimation. I'm giving you no information other than what we've already had in the video. All right, the first thing you're going to want to figure out is how heavy are they? So if we look at Mario, I don't know, let's just say he's 150 pounds, which would come out to 667 newtons. Now Donkey Kong, if you were a silverback gorilla, might top out around 500 pounds, which puts him at 2,225 newtons. Now the next tricky part is the distance, right? We don't have any indication of how high they're climbing. What you might want to do is take an estimate of Mario's height. So if we put Mario at 5 feet tall, it's about 1.5 meters, then you can actually stand him on top of himself to see how many Marios it takes to reach the top. If you do that, it comes out pretty darn close to 10 Marios. So 10 Marios at 1.5 meter each will be 15 meters. So that means when Donkey Kong climbs up the first time, he's going 15 meters. And it turns out it takes him 5.23 seconds. Now for Mario, he's a little bit different. He has to climb higher to get the princess. So he climbs up a zigzag arrangement of ladders and broken ramps. And he travels probably about 2 Mario heights further. So we're going to go with 15 plus 1.5 plus 1.5 meters, which will put him at 18 meters for his total distance. Again, only concerned with the Y component, not the back and forth zigzaggy X component. And Mario takes about 62 seconds. Now if we look at that, that should be our second round, which is where you're doing the calculation with some better estimations that we just provided you. So go ahead and do that. We'll come back and do the calculation in the third level together. All right, so we've got our measurements and our estimations for both Mario and Donkey Kong. And it turns out just how you might have expected, which is that Donkey Kong is way more powerful. Donkey Kong coming in at 2,225 225 newtons, goes up 15 meters in 5.23 seconds. His power is then 6,381.45 watts. Whereas Mario, who is lighter and takes way more time, but climbs a little bit higher, ends up being far less powerful. So Mario at 667 newtons goes up 18 meters, and it takes him 62.09 seconds, clocking in at a final total wattage of 193.36. And there you have it. In order, our most powerful people or animals will be Donkey Kong in first, followed by Katie, then Greg, then Super Mario, who at the time I think was just regular Mario or Jumpman, and in last, Dan. But all participants did a fantastic job. Thanks so much for watching. Let me know if you got any good feedback. Put it in the comments below. Take care, everybody, and stay powerful.